Hi there, and welcome to Mr. Morgan's Math Help for Algebra 1. We are looking today at Unit 1, One Variable Statistics. It's called Lesson 7. It's called Spreadsheet Computations. It's also an optional lesson in this unit that you may or may not have done in class. For learning goals, it says let's use spreadsheets as calculators. We're going to be using a spreadsheet again today and helping us solve some sort of problems. And learning target is I can use a spreadsheet as a calculator to find solutions to word problems. That's what we'll be able to do by the end of this lesson. So first of all, for a warm-up, it says, all right, a person walks 4 miles per hour for 2.5 hours. How far do they walk? So we have a couple pieces of information here. We know they're walking 4 miles every hour, and they're doing that for 2.5 hours. So in the first mile, they're walking 4 miles. In the second hour, they're walking 4 miles. And then we're walking for half of an hour. So we'll do half of the 4 miles per hour for about 2. And we'd say that looks like about 10. Now, of course, there are other ways of doing this. We could do something like, 4 miles per hour times 2.5 hours. We multiply together. And we have 8, 9, 10, 1 decimal, and we say 10. So how far do they walk? 10 miles or 10 miles. Couple ways of looking at that, depending on how you want to do it, right? Okay, a rectangle has an area of 24 square centimeters. What could be its length and width? Well, recall that the area of a rectangle is equal to the length times the width. As a result, we would say, since we know the area is 24, we're going to need two values that can be multiplied together to get to 24. So think about your math facts. Which numbers could you multiply together to get to 24? You could have something like a length of 24 times 1, something like that. You could have what else? 12 times 2. We could also have a 6 times 4, right? It's 24. I skipped one here. We could have an 8 times 3 if I was to go in order. Okay, these are all options for what we could have. Okay, and you might think of some other ones too, but that's some good ones. You might be a little creative. Maybe you can do one that's a 48. What would that be? 48 by what? 48 by, well, if this is doubling it, 48, then we're going to make that go down to how about 48 times a half? That'd be interesting, wouldn't it? So lots of options here. And finally, what's the area of the triangle? Well, remember that the area of a triangle is found by doing 1/2 of the base of the triangle when it's a right triangle, which this one is, right triangle right there, times the height. So in this case, we have 1/2 times the base, which we would use the 8 there, like even number, times the height, and that's the one that comes off the right angle. So we're going to say 15. So half of 8 is 4. 4 times 15 is 60. All right, and we don't know what the units are, so we would just call them square units. All right, so good warm-up. These kind of questions here are going to tie into your homework later on, so just kind of keep those in mind for when you get to the homework section. All right, let's take a look at number 1. Activity 7.2 says to use a spreadsheet to compute each of the following. Type each computation in a new cell instead of erasing a previous computation. So we're going to put all of these into a spreadsheet to be able to figure out what the solution is going to be. We're using a spreadsheet as a calculator. All right, so we're going to take these numbers here. For me, I'm going to go ahead and just switch over to my spreadsheet, and I have one open here. And the first one said, what I'll do is I will type into here what it says to do. Number 1 said to do 2 plus 7. Now, it's not going to solve it as 2 plus 7. That's just what I'm doing for number 1. So to make that as a solution, I would do the equal sign, and then a 2 plus 7, as so, with no spaces. And when I hit enter or return, I get the solution. Okay? The next one is 2 minus 7. So as an equation, if we're going to use the spreadsheet as a calculator, I'll type the equal sign and then do 2 minus 7 and enter. And there we have our solution. The next one is 7 times oops, times 2. So as a equation, we're going to do the equal sign, and it'll be 7. And recall the little star above the 8, that is our multiplication. So 7 times 2 looks like that. And equals is 14. So we know that the star, it means to multiply. All right, the next one we have 7 squared. I can't really write that there. So let's do 7 squared. So 7 squared, this little what's kind of called a caret, which is above the 6, means to, is like an exponent. We're going to raise it to whatever number comes after that. Okay, so if I want 7 to the second power, I would do 7 raised to the second power, or 7 squared. Well, 7 squared is 7 times 7, so I expect when I hit enter for 7 times 7 to be 49. Oops, what did I forget? I forgot my equal sign. If I don't put an equal sign there, it's never going to know that I should have, that this is an equation. Oops, get rid of that one there. And equals. There we go. That's what I'm looking for. Perfect. The next one is 7 divided by 2. And division is written with the slash like this. Divide. So let's do that then. We'll do 7 divided by 2. Oops, don't forget the equals. Equals, this cell is going to equal 7 divided by 2. So remember to start with the equal sign. And we have 3.5 as an answer. The next one is 1/7 of 9. Okay, so in this one, we're going to say it's equal to, first thing we want to do is to find 1/7. So the parenthesis says to do that first. Of means multiply, and then 9. So we're going to have 1.28, some crazy number there. So remember, the parentheses means do whatever's inside of here first. Okay. All right, we have 0.1 plus 2, times 2 plus 3. So for this one, we're going to go ahead and put an equal sign here. I can say that I want to do the 0.1 times 2 first, and then I want to add 3. One common mistake people make with their cells here in spreadsheets is they start adding spaces. Don't add a space. If you don't need to add a space, don't add a space. So we're going to just group it all together like that, and it reads it as 3.12. And then we have 0.1 times 2, looks like 2 plus 3. So because there's parentheses here, we're going to say we want to equal to, and we can say 0.1 and multiply by 2 plus 3 like that. So much like the equation, and it'll solve it for us. Perfect. Okay. All right. So the difference between this one and this one is the first one we're multiplying 0.1 times 2 and then adding 3 to it. Here we're adding 2 plus 3 together for 5 and then multiplying that sum by 0.1. Next we have 13 divided by 1/7. So we would say equals 13, and then in parentheses 1 divided by 7. So 13 is going to be divided by 13 divided by 1/7, just like that. And then finally, number 10 said the average of 2, 7, 8, and 11. So we're looking at the average of 2, 7, 8, and 11. So to find the average, what's handy about the program here is we can type in the word mean. It knows it's the average. And just type in the numbers 2, 7, 8, 11. Now here we do use spaces, okay? Because we're spacing out the commas. Oops. That one didn't quite like that, did it? So name. Oh, probably because I'm using my Apple thing here. So let's try, instead of mean, let's try, I'll go down a cell. let's try average equals average. Right here. Yeah. Let's try equals average 2 comma 7 comma 8 comma 11. That worked there. Okay, so on my Mac, or on Mac, on this Google sheet, it wanted average. When I used mean, it didn't work. Mean might work if you're in Microsoft Excel. So it depends on the program there. So mean didn't work, but average did. If neither of those worked, you could make an equation where you just add it up and figure it out like so. Okay, so that's our first activity, and we've now done all those there on our spreadsheet. Let's look at the next activity. 7.3, use the contents of a cell in a calculation. So we have, in this case here, 6 things it wants us to do by typing numbers in cell A, other things in A2, and then in A3, doing some other things here. I have all this information right here already pre-populated in my spreadsheet. So let's go back to our spreadsheet. I'm going to click on the bottom, activity 7.3. And you can see on the side right here, I have all those same questions right there. So here we go. Number 1, it says type any number into cell A1 and another into cell A2. So I'm going to type in a 2 and I'll type in a 4. Then in cell A3, type A1 plus A2. Now, by doing that, nothing happens. Why doesn't anything happen? Well, it's because I forgot to tell it that I wanted to do something. I want to say that I want to find what it's equal to. So, what I'm going to do is go right in front of the A1 and put an equal sign. And once I do that, notice that it lights up. A1 and A2 light up there. Now, I should notice here, I did something wrong, which was what? Well, you notice my answer is 2. What did I do wrong? Oh, it's A1 and A2. I typed it in B1. Let me put the number 4 in B2. Notice what happens in C1 once I do that. Oh, it changes to 6, doesn't it? Okay. So it wants to, in cell A3 is where I have to do this to do equals A1 plus A2. There we go. That's better. So I'm going to get rid of this guy right there and follow my own directions. So in A1, I wrote 2. A2, I wrote another number 4. And in A3, I did equals A1 plus A2. Now in cell 4, number 2, it says compute the product of the numbers A1 and A2. So product means multiply. So say it equals A1 times A2. And we hit enter, so 2 times 4, up here, 2 times 4 is 8. Looks good. In cell A5, compute the number A1 raised to the power of the number in A2. So it's going to be equal to A1 and raised to whatever the value of A2 is, so the 4th. This is going to be 2 to the 4th power, or 2 times 2 times 2 times 2. Which is 2 times 2 is 4, times 2 is 8, times 2 is 16. So when I hit enter, I expect to see 16. And there it is. Okay, now if I type a new number into A1, what's going to happen? Let's say I change this into just a 1. Changes all my values, doesn't it? My sum becomes 5. My product becomes 4 times 1 is 4. And then the next one for the 1 to the 4th power is simply 1. Okay. It says use nearby cells to label the contents. And this is just a good practice, right? This is just my first number, so I don't have to label this one necessarily. My second number for this one. This is the sum of A1 and A2. This is the product of A1 and A2. And this is A1 raised to the power of A2. So it does help by doing that. Now when I change my numbers around, if I have a 4 there and a 5 there, now I know what these numbers mean. I know this is changing, and this is changing, and this is changing based upon what these first two numbers are each time. Okay, So, for example, it says in cell B3, type in the sum of A1, A2, which, okay, cool, we did that. So just a few things to remember here, that this little star above the 8 is multiply, the little caret above the 6 is to how you do the exponent, that slash by the question mark is divide, and parentheses tell you what to do first. So again, we're just using the spreadsheet as a fancy calculator. That's all that we're doing there today, okay? All right, so let's take a look at the next thing. Go back to our slide. All right, for each problem, estimate the answer before calculating, use a spreadsheet to calculate it, and then write down the answer and the formula you used. Okay, so let's take a look. Number 1, the speed limit on a highway is 110 kilometers per hour. How much time does it take a car to travel 132 kilometers at this speed? Okay, so in this case here, we know it's going to do 132 kilometers, right? 132 kilometers. And we're going to multiply that by 110. We're going to multiply by every 1 hour, it does 110 kilometers. Now I'm going to set it up that way so that when I multiply this, I can actually eliminate the kilometers, and I end up with 132 divided by 110. And 132 divided by 110 becomes 1.2. In this case here, what's left? Hours. So what am I doing? I'm doing 132 divided by 110. So in the cell, if you were to use your spreadsheet, we would say equals 132 divided by 110, or really we would say 132 divided by 110. Okay, so I'm taking the 132 kilometers and I'm dividing it by 110 kilometers per hour. Okay, all right, number 2. We could do this real quick, just double check. 132 divided by 110. Let's go to here, and we can go to, well, we can really go anywhere. Let's go right here in the cell. We can go equals 132 divided by 110 using a spreadsheet as a calculator, and we get 1.2. Does that work? That works. Perfect. All right, next one. In a right triangle, the lengths of the sides that make a right angle are 98.7 centimeters and 24.6 centimeters. What is the area of the triangle? Well, our formula would tell us that the area is going to be equal to 1/2 of the base, doesn't matter which one you use, times the height, 24.6. On a calculator, or on the spreadsheet, we would probably write down equals, and we would say 1 divided by 2, and then we could say times 98.7 times 24.6, and that should give me my solution. Okay, so let's take a look here and see what our solution is going to be. So it's equal to, we said 1/2, or 1 divided by 2, times, and our second number was 98.7, and we're multiplying that also by our other length, 24.6. And I said equal, we'll have our area, so 1214.01. So our area is going to be 1214.01. These are centimeters, so we would call them square centimeters. All right, and our last one, it says, a recipe for fruit punch uses 2 cups of seltzer water, 1/4 cup of pineapple juice, and 2/3 cup of cranberry juice. How many cups of fruit punch are in 5 batches? Okay, so in one batch, we're going to use 2 cups of seltzer plus 1/4 cup of pineapple plus 2/3 of a cup of cranberry. The but that's one batch. To make 5 batches, we'll take that whole amount and we'll multiply it by 5. Follow me so far? So now let's put that into an equation. As an equation, I could say something like, set it equal to, and we could do 2 plus, and then in parentheses, 1 divided by 4, plus, in parentheses, 2 divided by 3, and then another parentheses, I gotta close it out there, and then times 5. Let's see if that works. So let's see if it works again. Look at my notes here. All right, so look where I'm looking at here. There it is. So really small. All right, so we're gonna do equals 2, oops, let's do parentheses, 2 times 1 divided by 4 times, we said 2 divided by, oops, in parentheses, 2 divided by 3, and then we close that all off to go together, and then we multiply the whole thing times 5 batches. And we get 1.666. How many cups of fruit punch are in 5? That doesn't quite look right, does it? So I did something wrong here. Let's see. I had 2 cups there. Times I know what I'm doing wrong. I'm not going to multiply those. Oh my goodness. I'm adding that, aren't I? I'm adding, not multiplying. By multiplying, I made it smaller. So I need to add 1/4 of a cup, and then add 2/3 of a cup, and then multiply the whole thing by 5. That's what I did wrong. Okay, I need to add those values together because I'm just adding the mix, and then I multiply by 5. Let's see what that comes up with. I should get a better answer, not 1. That's not going to work. Hey, 14.58. That looks a lot better. So 14.58 cups of juice is about right there. 14.58. Oh, and look on my notes, what did I do? I added and I added. I just got confused when I typed it in without looking at my notes. So here we go. All right, perfect. Number 4. Checking with the partner, resolving discrepancies with your answer to the last question. Hey, I checked myself. Good job. Now type 2, 1/4, 2/3, and 5 in separate cells. You may find it helpful to label cells next to them with the meaning of each number. In a blank cell, type a formula for the total number of fruit punch that uses the values of the other 4 cells. Okay, now you should easily be able to figure it out. Okay, so let's pretend here that I won't do it. That in cell 1, I have 2, and then in 2, I have 1,4, right, is equal. 3, I would say it equals 2,3, so I have a number there. And then in 4, I would write down the number 5. Okay, so then in cell 5, what I might write down is I could say, I'm going to take, let's call these all A. I could do A1 plus A2 plus A3. Say it's equal to, parentheses, A1 plus A2 plus A3 times whatever's in A4. And that should give me the same answer if that's what I type there. Okay? All right, so how much is in 7.25 batches? So let's go back to my little mixture over here. Okay, and so in those batches there, what I would change is I'm going to change the number 5. Instead of having a 5 there, we'll change that to 7.25 batches. 7.25 batches. And we end up with 21. In this case here, we end up with 21.145 cups. Okay. How much, next question says, how much in 5 batches if you change the recipe to 1.5 cups of seltzer water per batch? All right, so let's see here. Right now, let's change this number to a 5. The seltzer water was, looking at the notes here, the seltzer water was 2 cups, so now we're going to make that into 1.5 cups. So let's go back to our 1, instead of a 2, I'm going to delete the 2 and turn it into a 1.5, and then hit enter, and we end up with 12.08. Okay, it's coming back here. With 7.25, we said it was about 21.15 cups. When we change that to have it be less, we have 12.08 cups. And then change the ratio of ingredients in the fruit punch so that you would like the flavor. How many total cups are in half a batch? Well, that's for you to do. So you could change it however you wanted to do it, really. It doesn't make a big difference there. So if I don't like that formula, if I want to make it better and I only want to make half a batch, I'm not going to multiply it by 5. I'll multiply it by 0.5, so half a batch. And maybe I want to have, I want to have more, let's go more pineapple juice. So instead of 1/4, I do a half, and then I have less of the other juice. I do a 1/3, and then I end up with 1.16 cups. So whatever, you're going to make up your own thing for whatever that's going to be. The idea here is just getting comfortable using the spreadsheets and being able to make equations, okay? As you do it, remember what's happening is you're putting that equal sign in front of whatever you're going to put in each cell. So don't forget the equal sign. Just take some practice, and you'll get better with time. So, in summary, a spreadsheet can be thought of as a type of calculator. For example, in a cell, you could type equals 2 plus 3, and the sum of 5 is displayed in the cell. You can also perform operations on the values in other cells. For example, if you type a number A1 and a number in A2, and then A3 type equals A1 plus A2, then A3 will display the sum of values in the cells. So familiar yourself with how a spreadsheet software works on your device, and then just remember they do vary. Different devices work in different ways, okay? But you need to have that equal symbol before, okay? And then just know what you got to do, okay? Here are some examples of some basic symbols and how they work, just so you have that as a reference for yourself for later, okay? All right, here is your cool down for the day. So take a look at that. If you're in class, you probably want to do the cool down before you take off. Show your teacher you're understanding stuff, and then you go on home and do your homework. As always, do the homework and then come back and finish checking to see if it's making any sense to you today. All right, homework time. Write a formula you could use and type into a spreadsheet to compute the value of each expression. All right, so a formula for this one here would be something like make it equal. We could do parentheses 19.2, and then we would do the little star and 73. For the next one, we'd say equals in parentheses 2.34. Division is going to be the bar like this and the number 5. For B, we'll say equals 2, and we'll do 1.1 in parentheses, right? You don't necessarily have to do parentheses, but I like to. We'll do the caret and then the 5th power. And the last one, we do 91 divided by 7. Okay, that's pretty much about it there. All right, number 2. A long-distance runner jogs at a constant speed of 7 miles per hour for 45 minutes. Which spreadsheet formula give the distance she traveled? Notice it's 7 miles in an hour, and they only went 45 minutes. So we're not going to do it for a whole hour. If we go 7 miles in a whole hour, right, if this is my hour here, 1, 2, 3, 4, 5, 6, 7, right, we didn't fill them all the way up. We only went 3/4 of the way, right? 45 minutes is 3/4 of an hour because it's 45 minutes out of 60. So we didn't complete it. So we know we're not going to have all this filled up. We didn't get 7 miles. I should have an answer less than 7. So on the first one, they had 7 times 45. That would be true if you had 45 hours, but we have minutes. So that doesn't make any sense. 7 divided by 45, well, 7 divided by 45 minutes, that doesn't make sense either because we're not going to do that. It just doesn't, that's going to be a really small number. You're going to get like 1/6. Here we're multiplying by the number of minutes that they ran, or really number of hours, because 3/4 is 45 minutes, right? If it was 1, we would say they went one. If we went 1 hour, we do 7 miles. 1 hour equals 7 miles total. In this case, they went 7 miles per hour, but the number of hours they ran was 3/4. So C seems to make the most sense. This last one, again, doesn't make a lot of sense. 7 divided by 3/4, no. Number 3, in a right triangle, lengths of the sides that make a right angle are 3.4 meters and 5.6 meters. Select all the spreadsheet formulas that would give the area. Remember, area is going to be 1/2 times the 3.4 times the 5.6. All right, so we need to have those numbers in it. I got 3.4, 5.6, but no half, so nope. 3.4, 5.6, I have a 2. Nope. 3.4, 5.6 divided by 2. Well, order of operations here says that I would do this first because of how it's written, left to right, order of operations, and then dividing by 2. Dividing by 2 is the same as multiplying by 1/2, so that one's going to be okay. 3.4 times 5.6 times 1/2, that looks great. And then 3.4 times 5.6, this one does have the parentheses there like we did there, and divided by 2, so it's the same. That's going to work as well. Number 4, this spreadsheet should compute the total ounces of sparkling grape juice based on the number of batches, ounces of grape juice in a single batch, and sparkling water in a single batch. So these are our batches. We can see here's 4 batches, and you have 3 ounces of grape juice, 7 ounces of water for total ounces there. Write a formula for cell B4 that uses the values in B1, 2, and 3 to compute the total ounces of sparkling juice. Well, the sparkling juice is going to be equal to B2, right? The 1 ounces of grape juice plus the B3. We'll put those in parentheses, and then we're going to multiply it by the number of batches, 4. Well, in this case here, we're going to say B1. Okay, so in this case, for this first one, if we were to do it, we would say that you have 7 plus 3 times 4. So we have 10 times 4 is 40. So we get 40 ounces right there. For B, how would the output of the formula change if the value in cell B1 was changed to 10? So if this changed to 10, we'd multiply everything by, instead of B1, instead of multiplying by 4, we'd multiply everything by 10. I have 10 times 10 is 100. I'd end up with 100 cups, or 100 ounces, instead of just 40 ounces. So I get a lot more there, that's for sure. What would change about the sparkling grape juice if the value in B3 was changed to 10? So if I change that to 10, what would happen to the sparkling grape juice? Well, we went from 7 to 10, so we're increasing what? We're increasing the water. When you increase the water, you have a more watery drink and less grape juice. So it's a little more watery, maybe less sweet, maybe not as flavorful, because you're adding more water than juice. Number 5, the dot plot and box plot represent the same distribution of data. How does the median change when the highest value, 5.2, is removed? Okay, so median is the middle number, right? That's our middle number. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So let's find the middle, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our middle is going to be right there. Okay. So if I get rid of that guy right there, now I have 19. So my median is going to go back 1, in this case here, would go to this spot. Well, notice it's still at 3.5, isn't it? Nothing's really changing there, right? So it remains 3.5. Now, how does the interquartile range change? Well, the interquartile range might change a little bit because our median now is here at 3.5. I'm going to draw it right below it. Let's do that here. So my median is still at 3.5. That's for sure. Right, there's my little line right there. Now I need to find the middle of this. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's my middle number here is there. So there's my quartile 1, same spot. But over here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10? That seems weird, doesn't it? 1, 6, 7, 8, 9, 10. Yeah, so 10 and 10. Okay, so till 10. So we go 1, 2, 3, 4, 5. And 1, 2, 3, 4. Oh, yeah, sorry, it goes here. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So my median here of that quartile is at 3.95. Notice it's between the 9 and the 4. So 3.95 is actually here for my quartile range. The low is still at 2.9, and then this one's at 5.1. Okay, so how does the interquartile change? Well, before the IQR, remember the IQR is Q3 minus Q1, right? Which I messed up in my first lesson, but I fixed it up later on. So initially, our Q3 was here at 4.1 minus 3.1. So our IQR initially was 3. Now our IQR is at 3.95 minus 3.10. So now when I do some subtraction there, I do end up with a different answer, okay? So in this case here, my IQR is changing from, in this case, sorry, why did I put 3 there? From 1 to 0.85 is what I have here. Now my notes say it's a 0.9. Either way, so I'm probably doing a little bit of math wrong somehow here. 3.95, yeah, that looks right to me. I don't know. I think it's 3.95, so I think it should be 0.85. So I went from 0 decreasing down to 0.85. So my IQR became smaller, which means there's less variance, right? Because it's getting smaller because I got rid of an extreme number there. Okay, number 6, describe the shape of the distribution and shown. So this one goes up and then pulls off that way. So because it's pulling off to the right, we would say it is skewed right, because it's pulling to things to the right. Okay, and it has a center. The center is probably right about here, about 600. So the center is going to be a little bit this direction. Should be more like 500, but it's going to be pulled a little more to the right. Number 7, the dot plot represents distribution number of goals scored by a soccer team in 10 games. All right. If possible, find the mean. Sure. Well, the mean's going to be add them all up. We have 0, 0, 0, 1, 1, 1, 1, 2, 2, and 4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 divided by 10 games. So the number of goals per game, 1.2 goals per game. If possible, find the median. Well, 10 games, we're going to go for 5. 1, 2, 3, 4, 5. And draw a line right there, separate. 1, 2, 3, 4, 5. So the median is going to be 1. No problem there. Okay. Did the soccer team ever score exactly 3 goals? Well, we look at 3, and what do we see? Nothing. So we would say, no, it did not. All right. That's it for the day. Hope that helps you out with this lesson. Again, it's an optional one, and we will see you back here next time. Have a great day. Bye-bye.